I did.
Why? That's awesome.
No.
Good job. Okay. If you want to look at the video again, it's on YouTube. Good morning, YouTube. Today is Thursday, October 25th, 2012. You'll watch it. Do you know how to get there? I did. Alright, so a scale drawing is a scale model. It's used to represent an object that is too small or too large to be drawn or built at actual real life size. So when architects design buildings, they have to do a little model. And then they look at the model and they try to fix it and they make it bigger. When they design cars, they make little model cars and they use like clay. They actually use clay to like kind of sculpt the body of the car out, and then they put in the computer and then they make a real car. It's real interesting. So here the scale. A scale is a ratio, R-A-T-I-O, of a length on a drawing or model to its real or actual. Thank you. Ooh. Actual or real length. All it is a fraction to the real life.
Are we doing model actual proportion?
So like on paper, you can write it down, you can draw the picture out, right? In real life, you can actually build it, and it's true. Real form. So remember that distances on a scale drawing are, so to the P when working on this. Proportional. Good. Proportional to distances in real life. That's why when we talk about proportions, two fractions, they're equal to each other, they're the same proportions. Don't forget you'll get your progress report today, 5th period. The grade may or may not be accurate. You may have made up things before since it got printed yesterday. Okay. Now looking at number 1 here. Looking at number 1, a drawing is 10 inches and the actual measurement is 20 feet. What is the scale? It's asking you to set up the scale, the fraction. So what you do first, Emily, is we set up what we know. What fact do we know? Okay, so we know it's 10 inches and the real measurement is 20 feet. Okay, inches and feet. We have inches and feet. How many inches in 1 foot? 12 inches in 1 feet. 12 inches. Get that out of your mouth. I don't need you choking that in another class. We will not do CPR on you. 12 inches in a foot. Alright. So 12 inches in a feet, right? So then we match up inches and feet. Inches in the problem. 10 inches. And then 20 feet. If it's 10 inches over 20 feet, then if I reduce my fraction, what's my reduction here? See 10 and 20? So that means for every 1 inch, what does that equal? 2 feet, or 1 over 2. That is your fraction. So on your ruler, for every inch, is 2 feet in real life. For every inch, is 2 feet, another 2 feet. For every inch, this is another 2 feet in real life. So if you want to be an architect or whatever, these are the things you need to know. If you work at, like I work at Lowe's, I have to know how to use a ruler all the time.
What's Lowe's?
One on Northwest Highway. Plumbing. I know you. I saw you too. Okay. I do a lot of plumbing jobs on the side. And I use a ruler all the time because all pipes are very small. I have to know how to use 5/8 and 3/16 and all that stuff all the time. So if it's a little off in the fitting, it's going to leak everywhere. Sit up, please. Okay. Now, look at number 2. Going to work at number 2. It says, number 2 says, a model of a planned baseball stadium is 2 feet wide. The model is 2 feet wide. The real stadium, it's 200 yards wide, or the length of 2 football fields. What is the scale? Set it up as a fraction and then reduce.
I don't know how many feet.
3 feet in a yard. No. Yeah, 3 feet in a
Are you
yard.
going to give us
yardstick, right?
I think it's 100 feet.
Our feet,
The paper.
like, can anybody still be that big?
Well, think about how. Well, think about back in the day, back a long, long time ago, like medieval times. They figured out that a foot is about 12 inches, right? Because that's the average size of a person's foot.
What? Why? Well, I'm talking about.
So like here, this is yardstick 1, 2,
The measure.
yardstick.
Are there just one of those papers for the measure?
Yes, it's on the back of the chart. I'll give you some later. But you don't need that on tonight's homework. You do? That's great. All right, let's go over it real quick. Ready? All right. Now, we know that we have feet and yards. Remember that there are 3 feet equals 1 yard. A yardstick. 3 of these together. Yardstick. Okay. So then, what do we know then? So for 2 feet, it's going to be 200 yards. So in real life, 200 yards is 2 football fields. Right? You have 100 yards, and then 2 football fields is 200 yards. So then when we reduce this fraction, what does it reduce down to?
100.
So for every 1 feet, it's 100 yards. So when they build this big giant model, 1 feet is 100 yards. So 2 rulers will be 200. That's about 2 rulers.
What is that?
What's what?
The other one.
I don't know. It's a ruler.
Oh, yeah.
From-
Backwards?
I'll show you later. All right, here we go. Let's do number 3 together. On the STAR test, you'll have to do some translations, translating from yard, inches, and feet and measurements. So if you have a drawing and it says that the scale is 1/4 inches equals 6 feet in real life.
25.
Okay, so 0.25, not 25. 1/4 is a quarter. 1/4 is a quarter. 1/4 is a quarter. So translate the fraction into a decimal. So 1/4 is a quarter. So we know we have 0.25 inches is 6 feet. That means on the ruler, for every 1/4 inch, let me zoom in here. For every 1/4 inch, there's 1 inch and there's 0. Quarter, 1/2, 3/4, 1. 1 1/4, 1/2, 1 3/4, 2. There are 4 quarters in a dollar, right? So if you have the long marks, those are quarters. So here, if we know that this is 25.25 inches is 6 feet, how many feet is 4 inches? Is it fair that I set it up as a proportion? Can I set that up as a proportion? Yeah, I can. Look, I can, right here. Inches. 4 inches. See that? Inches, inches. Find the feet. X feet. I can set up as a proportion because I have allowed myself to translate and set it up as a ratio. So here, it's a proportion. You can cross multiply. Cross multiply to solve for x. 0.25 times x is 0.25x, and then 4 times 6, 24. Okay. Questions on how I set it up? Remember, you were responsible for this. It comes down to it. It's just you, not me. Divide both sides by 25. Remember, students, top in, Leslie, bottom out. But I need to fix that. I can't have that. I can't do it. Can't do it, son. Can't do it. Right here. Can't do that. Move it to the end. 1, 2. That means I have 2. 1, 2. So I'm adding 2 zeros. Now I have 25 into 2,400. How many quarters do you need for $2.40? Now it's $1.25. 8 is $2. 9 is how much? 9 quarters is how much money? 225? So, okay, so you need about 9 quarters. So that's 225. So 40 minus 25? 15. Bring down one more zero. How many quarters is $1.50? Now. 6 quarters? 6 quarters. You see, put this in things that you know and you can see. You know? So how many feet is this in real life? 96 feet. That's about a football field. Almost a football field. You can see that in your head. Oh, 96, I'm sorry. 96 feet's about 3, let's see, this room is 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. It's about 33, 6, 9, 3 classrooms long. 3 classrooms long. Each tile is 2 feet. Can you see that now? 3 classrooms in a row. That's about 96 feet.
You weren't
Nope, that was not. True story.
You really like Pearson, or you were never.
I was not that smart.
You didn't pass.
Oh no, of course I passed. It's just wasn't smart. Like you, number 4. Oh, in math I was a straight C student. Math. C all the way.
But then how did you end up at college studying?
All right, go. You number 4. You. Try number 4 out, please. Same thing. Set it up. Same type of problem. Same measurements. Your answer is more than 60 feet. Same measurements. I promise. Number 4 is the same setup, using the same measurements, just like number 3. Yes, sir.
Were you 6 feet?
Yes, ma'am. Get it? Keep going. Good. I think the reversers are next. That should be outside. You're divided by 2.75. So 24 to 1. Don't skip any steps. Okay? You are accountable for your own learning experience. No one else will do this for you. Good. All right. Now, see, most people have set it up. Same measurements from the first time. So we have 0.25 inches over 6 feet. This time we have 2.75 inches. Find the feet. So I cross multiply here. 0.25x equals, what's 6 times 2.75? Times 6, was that 30? 5? Is that 12, 16, 15? Is that right? It is? Oh my god. 16.50 or 5 divided by 0.25. Now don't skip this step. I saw some people do this and divide it wrong. So you're actually dividing. I'm sorry, I'm running out of space here. Top in, bottom out. You're actually moving 1, 2, Zoe. 1, 2. So now I have 25 into 1,650. How many times can 25 cents go into $1.65? How much money is that? $1.50. One more time. So this is going to be 66 feet. 66 feet. 66 feet. That's about 2 classrooms in a row. 2 classrooms. Questions? That's fun. No. Okay, let's see number 5. Number 5. Now we're venturing into geometry. A square has a perimeter of 60 feet. It tells you that the scale is 1/3 inches, it's 5 feet. What is the perimeter of the drawing? What do you have to first fix? 1/3 is what kind of decimal? It's repeating over and over again. Point what? 0.6 repeating? Yes? No. That's 2/3. 1/3. 0.3. So this right here, students, sit up please. We have 0.33 inches is 5 feet. Questions on how I got 0.3 repeating? Or how I got the fraction 1/3 what inches over feet? The question says the square has a perimeter of 60 feet. 60 would go on the bottom, feet and feet, 60 feet. X. So the X goes on top of 60 because we're trying to figure out the scale, like the small little drawing for that little picture. Okay, so go ahead and try that one out, and we'll be done very quickly. Yes. The most harm goes together. That's right. So make sure you have 2 decimals. The answer makes no sense. No. Take that right there. Stop pointing right here. Be careful with your decimals. Some of you guys are telling me it's like some giant number. It's not a giant number. So we're going to cross multiply right here. 5 times x. Joseph, yes. So you have 5x equals. Now, let's review how to multiply a decimal. 0.33 times 60. So here, I can just move over 1. That's 18, that's 19, that's 1. Is it 1,980? No! Please make sure your answer makes sense. It's actually 19.8 or 19.80. So here, 19.8. Questions on how I get 19.8? Divide by 5. Now let's think. What can I round 19 to? 20, right? So what's 20 divided by 5?
4.
Okay, look at the answer. Can it be 4? It's going to be a little bit less than 4, right? Just common sense. So this goes when 3 times? 15, 48.
You told me to say one number.
You had a 7.
I had 3.
Yeah, then you had a 7.
Oh.
It's actually 9. It's 45.
Okay.
You're welcome. 3.96 was it inches? So it's almost, I know that. It's almost 4 inches. Make sure your answer makes sense, people. Your math is right. It's just the answer gets wrong because you don't look at their decimal spot. So it's almost 4 inches right here. Turn around. Last one. Sometimes you'll see a fraction written with a colon. A scale model of a car is drawn with a scale of 1 to 12. What is the scale model? Is 185 millimeters long. How long is a real car, the actual car? Now, number 6 is confusing. Family. Number 6 is a little confusing. How do I write 1:12 in a fraction? Right, first number first, sit up please, Kendall. Second number last. So here, 1-112 is 1 over 12. Then, how do I know which one's the real and which one's the scale measurement? Rows used on the bottom, right? So the top is the scale. The bottom is the real. If the scale is 185, would you agree that the measurement of the real car is kind of it's bigger. Yeah. So here we have, where would 185 go?
Top. Right.
Is it top or bottom? It says scale model, scale to real, scale to real. So the number on the bottom would have to be a lot larger because we're talking about a real car. It's going to measure a lot longer than a scale would. So you're going to cross multiply, I think only once, and then you'll get the answer right away. So the answer should be a large number. Oh my God, I can't do this for you. Your answer should be more than 1,000. More than 2,000 actually. So, more than that. No. No. Yes. 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 Okay. Now, again, be careful about how you multiply. Here, 185 times 12, 5 times 2, 10, 8 times 2 plus 1, 17, 1 times 2 plus 1. Good. Add a 0, scoot over 1, 5, 1, 1. 0, 12, carry the 1, 12, 2. Excellent. So the real model is 2,220 millimeters long. Questions, comments? I am done. Anything else? Let's go over the homework. No? One second. Let's go over the homework first and we'll talk. Okay. No, it's okay. We're good with that. If you need to watch the lesson again, it's online. Let's do a couple together. Okay. Number 1. A drawing is 10 inches and the real measurement is 20 feet. Wait a second. That looks familiar.
That's on the no.
Oh, it is. Oh, just kidding. Let's do number 2. A model of a planned baseball stadium is 2. Wait a second. What happened here?
Some notes.
That one's on notes. Okay. Alright, tonight's homework, let's do number 4. 5. My bag. Oh, you should be found here, right? 4, 5. Let's do 7 and 8. 4, 5, 7, and 8. Is 11 on notes? Yes. Dang it. Is that on notes? No, it's not. This is number 12, 13, and 14. So on the front, I apologize. 4, 5, 7, 8, 12, 13, 14. 4, 5, 7, 8, 12, 13, 14. That's 7 problems in the front. On a separate paper, tell your friends. Don't tell me, I'm not your friend. On the back page. Yes, on the back page. All right, let's do some of these. So the school is being built, and it tells you the scale. What is the scale on the back of the homework? What equals what? 1 inch. Excellent. So we know we have 1 inch is 3 feet. Okay. So number 1, it says an existing gymnasium is 8 inches tall. How tall is a real gym? Well, we use a scale. If we know 1 inch is 3 feet, the real gym, the paper gym on paper is 8 inches. What's the real gym? X goes where feet goes. X, feet, inches, inches. So how many feet is this reel?
24.
Excellent. So on the back page, let's do numbers 2, 3, 4, and 5. They all connect together. The front, you do 4, 5, 7, 8, 12, 13, 14. The back, 2, 3, 4, and 5. They all connect together, so it's all one problem. Any questions on homework? Are you sure? Say bye, YouTube.
Bye, YouTube.